Okay, so a very good afternoon to all of you. So today we'll be discussing yesterday. We have just completed, not yesterday, the day before yesterday. We have just completed about the difference between the serial communication and parallel communication, and we will see that how these communications are takes place and how many classifications are there in the communication part. And in addition, obviously, we will see that how this particular serial communication can happen by using some special function registers. Okay, so now we will see that there are three categories. I mean, three ways of communication. Okay, this is the three ways of data transfer or information transfer. So every communication protocol or communication systems follows these kind of either of these three kind of mechanisms. Okay, so let us first start with the simplex. Can anyone tell me that can are you able, I mean, are you aware of this kind of simplex, half duplex and full duplex kind of communication? Do you know? Have you heard of?
Yes, sir, we are heard of. We are aware of that.
Okay, and any other one?
No, sir.
Okay. So now we will see that the simplex is the simplest uh, data transfer or information transfer mechanism. Just see that there is a single ended arrow coming from the transmitter to the receiver. That means just like um, your radio, your FM radio. So in the FM radio, what happens? You are just listening to the programs, whatever happening in the FM radio stations. Okay, so that means you are the receiver, and the radio station from where the information or the program has been transmitted, that is the transmitter. So you cannot reply to this. You cannot reply. With the radio. Okay, so you are only listening. So from the radio station to your radio receiver, only one way communication is going on. So this is the example of the simplex communication. Okay, now what is half duplex? Now half duplex is, do you any people have used walkie talkie or something?
Yes, sir.
Okay, so in walkie talkie
Yes,
what
sir.
happens, multiple users are there, and a particular handheld device is given to each of the users. And what happens whenever any user wants to communicate with the others or sends the information, then that particular user is the sender. Okay, and all the other users are the receiver. When one people is communicating with the handheld device, then no other people in the user group can uh, use the channel or can send the data. So at a time, there may be in the handheld device, transmitter and receiver both are there, but at a time, one user can transmit and other can receive. Clear? So at a time, two, three users cannot talk. Okay. So this kind of communication, just see here in the figure, just see whenever uh, this is somehow this is wrong. I'm just, let me correct it, because this will be in the this direction only. Okay, no, this is the correct one. So transmitter to receiver. Okay, so here you can see this transmitter to receiver at a time. So whenever this switch will be there, this switch will be here also. So at a time, one particular device can participate in transmission. Okay. Now in the full duplex mode, just your mobile phone or land phone, any kind of telephones. So what happens? Or WhatsApp also. So multiple users can transmit, multiple users can receive simultaneously, I mean parallelly. So this is the full duplex communication, is the most effective way of communication, so that the information exchange and their acknowledgement can be accessed and can be received by the transmitter and the receiver as well. Okay. So any confusion regarding this? No. Okay. So there are two methods of communication, serial communication. We have seen in the first slide also that the synchronous and asynchronous. So synchronous means, I mean, with respect to something. Okay. Now, with respect to what? The synchronous method transfer basically a block of data. Okay. That block of data contains uh, multiple bits that needs to be encoded in the transmitter and decoded at the receiver at a time, while the asynchronous transfers a single byte at a time. Okay. So these things, these asynchronous things and synchronous things, that also can be accessed by that can also be done by the 8051 microcontroller. But in case of 8051 microcontroller, you can remember that there is one UART is there, that is universal asynchronous receiver transmitter. So on this, on that particular block, if you can remember the block diagram, then you can see, just let me go back to this one if I can find out. Now I'm sharing this. This is the thing that have been provided into your study materials. Is it visible?
Yes, sir.
Okay, now you can see in this case there is a UART. Sorry, there is an UART. Okay, that is the universal asynchronous receiver transmitter. So by this way, this transmitter can transmit, and by this way receiver can receive. But at a time, they cannot be used at a time parallelly. So transmission and reception cannot be done parallelly here. Okay. So we will see whether it is correct or not. Okay. So I'm going back to this one. Okay. Now we will see that this 8051 chip has a built-in UART. Okay. So by default, this 8051 microcontroller is participating on the universal asynchronous receiving and transmitting. Okay. So here in 8051, to use to communicate with the serial communication, we need this max 232 chip. Okay. And this you can see in the figure, I'm just annotating. There is TTL side and there is RS-232 side. So do you know that what is RS-232? Have you seen it? RS-232?
Maybe this a LAN cable.
Not exactly. Any other things? You have seen it. I'm quite sure.
Yes, sir. It is provided in the side of laptop, sir. It's like
Yes.
uh, a joystick controller, sir. Joystick is so joystick ऐड करते हैं ना सर जैसे PS
Mm-hmm.
वो
Okay. So,
तो joystick हाँ वैसा
so
ही
you
रहता है.
can, yes, exactly. You are right. You can also find it at the back of the CPU cabinet and in the monitors. So there a small pins are there. If I can find out so that I can share.
Yes, sir. Before the HDMI cable, RS-232 was used.
Yes, that is right. So just let me show you this so that you can. Have you seen this kind of ports?
Yes, sir.
Okay, so these are nothing but RS-232 ports. So there are DB24 and DB9 pins are there. So DB9 pins, I mean that means there are 9 pins just like this one. This is the DB9 port, okay, and this is the DB24 25 port. So I mean these classifications are there in the RS-232 case. So we are going back to this one. So here we can see this RS-232 side. This is the RS-232 side and this is the TTL side. TTL side means in this side the microcontroller is situated. Okay, and in this side RS-232 is there. So here we can see this DB9 is used. Okay, and you can see this 11 to 11 and 10 to 12, these communications has been made with the microcontroller. And this is the MAX 232 is the interfacing IC without which we cannot communicate this 8051 to this RS-232 port. Okay, so just see that that RS-232 is the most widely used serial IO interfacing standard. In RS-232, 1 is represented by -3 to -25 volt and 0 is represented by +3 to +25 volt. So just reverse, okay? I mean just the opposite, just the complement. For conversion from TTL to RS-232 standard, MAX 232 chip is used. Understood that what is the use of MAX 232? Why cannot why this RS-232 cannot be directly used with 8051? Because this 0 and 1 logic microcontroller can understand only 0 volt and 5 volt. I mean in between these two. So it cannot understand -25, -3, +25, this kind of. So this MAX 232 chip particularly converts this RS-232 standard to the TTL standard that is required by the 8051 microcontroller. So that is the use of the MAX 232 chip. Okay. Now, just a minute. Yeah. So serial communication with this 8051, we will see that the baud rate. So what is baud rate? You know that what is baud rate? Can anyone tell me?
Sir, it is the timing, sir.
Timing for what? Timing for what?
Sir, maybe the clock speed for serial communication.
Okay, and anyone, any other people? Any other people?
बॉड बॉड रेट लाइक कोई फिक्स इंटरवल नहीं होता है सर, हम लोग खुद से प्रोग्राम कर सकते हैं कि कितना हम लोग को टाइमिंग चाहिए, वैसा कुछ।
क्लियर नहीं हुआ, फिर से थोड़ा सा क्लियरली बताओ।
सर वो आर्डिनो में प्रोग्राम करते वक्त इसका जरूरत पड़ता है सर, बॉड रेट कितना देना पड़ता है उसमें।
हाँ, but
सर
you need
मतलब
to know
खुद
that
से वो
what
हम
is
लोग
baud rate and why it is necessary. Now we can see in the slide that
सर
baud rate is
वेवफॉर्म
9600. Yeah, tell.
वेवफॉर्म सर वेवफॉर्म
Not waveform. That is not right.
Sir, changes of waveform per unit time.
What?
Sir, changes of waveform per unit time.
No. Raj, you were telling something. You can repeat this.
Yes, sir.
ऑसिलेशन सर।
In Arduino we use this.
No, not oscillations. Baud rate is basically the rate of transmission. I mean, obviously with respect to time, that rate means per unit time, and this is basically number of bits per second. Okay, just we are going back. We can go back to this one. You can see the data transfer rate is the rate of the data transfer at the bottommost slide. You can see the rate of data transfer in serial communication is stated in BPS, that is bits per second. It is also referred as this baud rate. Okay, so we can set just one of you told that in our Arduino programming we need to set the baud rate for the serial communication or parallel communication, whatever. So how that can be done in 8051? Look, the baud rate is to be selected with the help of the timer 1 with auto reload mode. Okay, because the transmission is a continuous thing. Okay, so these things needs to be maintained. So this timer 1 auto reload mode, that means the mode 2. Okay, so here this mode 2 of timer is very important. Okay, and clock for 8051 UART circuitry, that can be found out by the dividing the machine cycles by 32. Okay, and as we have said that for microcontroller 8051 can communicate with the receiver with different baud rates. Okay, so here also you can see this baud rate for 4 different baud rates have been have given, and their particular equivalent value is loaded in the TH1. Now there is a question also. I can see this why this TH1? Can anyone tell why H1 TH1 only?
The timer 1 mode 2 sir।
I cannot listen. Can you please repeat?
Sir, timer 1 mode 2 sir, because we are using timer 1 mode 2।
Timer 1 mode 2. So this is the case. So timer 1 mode 2, in mode 2 we need not to load any value to the TL timer low, because it is automatically loaded from TH1. Okay. Now for the baud rate of 9600, this thing is -3, that is FD. So again, how FD? So 3 needs to be converted to the 2's complement form. So 2's complement of -3 is FD Okay. Similarly, 4800, 2400 and 1200. Okay. Just see that whenever the baud rate is twice, the TH1 value is the half. That means 1200, for 1200 baud rate, the TH1 value is 24, but in case of 2400, the value of TH1 is divided by 2, like this way. Okay, so the maximum baud rate that can be achieved by the 8051 microcontroller, that is 9600. So 9600 means 9600 bits per second. Understood, or any questions?
Sir, is the TH1 is the 2's complement of TH1, that is -3.
Yes, this is the there is a column, just this is the column thing. Okay, ये थोड़ा लेफ्ट साइड में हट गया, इसीलिए शायद समझने में दिक्कत हो रहा है. So TH1 decimal value is -3 and TH1 hexadecimal value, because 8051 cannot understand what is decimal, right?
Oh, yeah, okay.
Okay, so we are going forward. Now SBUF register, we have already discussed that this SBUF register is the buffer register that is used for the transmission and the reception of the serial data. And for a byte of data to be transferred via this TXD and TXD line, this must be placed into the SBUF register first, because if we go back, just see here, to send the data using parallel in serial out register, and to receive data serial in parallel out register. So both these registers are nothing but SBUF. Okay, now we will going to there. Now this, for a byte of data to be transferred by a TXD line, it must be placed on the SBUF register. Similarly, it holds the byte of data received by 8051 through RxD line. Clear? So this is the use of this SBUF register. Look, this SBUF register is not bit addressable, so it can be accessed by a block of data. And if we are going forward, then we'll find that the SCON register, that is the serial control register, is an 8-bit register used to program the start bit, stop bit, and the data bits of data framing. Okay. Now serial, you can see in the serial control, serial communication control register, there are 8 pins, 8 bits is the 8-bit wide register, and this is the you can see this SM0, SM1, SM2, REN, TB8, RB8, T1, R1. Okay, so what are the functions of these three, these bits? Now SM0, SM1 and SM2, this is the serial port mode specifier. Okay, now you can see, we will see again the serial communication modes. There are different serial communication modes, just like the timer counter mode. We will find out here also the serial mode specifier. Okay, now the serial ports, we will see that SM0 and SM1, this is the, SM2 only. SM2 is used in the mode 2 and mode 3. And set to what is mode 1, mode 2, mode 3, we will come to that. And set to 1 when bit 9 of the received data is 1 and an interrupt is generated. Now you can have a question like, sir, you have told that in the serial transmission only 8-bit data can be transmitted, and SBUF register is also 8-bit. Microcontroller can process 8-bit of data. So why, sir, this is written when bit 9 of the received data? From where this 9th bit comes? We will come to that. obviously it will rise a question like this. So we will discuss. So REN, that is the receive enable. Okay, REN means receive enable, that is set or cleared by the software to enable or disable reception. That means if this REN pin is set, then just a minute. Yeah, so this if this REN pin is set, then receive enable, I mean that means the data can be received. Okay, and when this pin is 0, that means receive not enabled, that means the reception cannot be done. And TB8 RB8, that is the transmitted bit in transmitted bit 8, that means the last bit in mode 2 and mode 3 set or cleared by the program, and RB8 the received bit in mode 2 and mode 3, and obviously this is the stop bit in mode 1, but it is not used in mode 0. So as of now we have learned that there are 4 modes available in the serial communication also. There is mode 0, mode 1, mode 2 and mode 3. Okay, and transmit interrupt flag, that is the T1 and R1, that is, and receive interrupt flag. So transmit interrupt flag, that is set by hardware at the beginning of the stop bit in mode 1, and that must be cleared by the software. Now receive interrupt flag, that is set by the hardware halfway through the stop bit in timer mode 1, and that needs to be cleared by the software. Okay. Okay, so okay, we will continue this to tomorrow's class. Okay, so I'll just share this thing. Just record this, and after recording you may leave the class. Okay. Okay, so I'm ending the meeting. Thank you.